Welcome to NCIX Tech Tips. This, my friends, is the most GTX 780s that I've ever seen in one place. We are going to take you through the ins and outs of comparing EVGA's reference model, MSI's gaming model, Galaxy's GC model, EVGA's superclocked model with their own custom cooling, ASUS's DirectCU 2 model, and finally, Gigabyte's WindForce model, all based on the same GK110 core with 3 gigs of RAM and a whole lot of performance. So the test bench that was used was a 4770K, a Sabertooth Z87, 16 gigs of memory, and that's pretty much all you need to know. In terms of applications, Hardware Monitor was used to monitor the temperatures of the graphics cards, and 3D Mark Firestrike was used to get benchmark numbers out of them. Now, normally, I advocate against the use of synthetic benchmarks, but in this case, I was talking to Wheels, who actually ran all the numbers, and I was like, well, they're all the same architecture, so using a synthetic actually does give you comparative numbers between these because there's no architectural optimizations going on. It's just which one is actually able to maintain boost clocks better than the other cards. And that's what's important, guys, because with GPU Boost 2.0, temperatures make a big difference to how fast the card will run, even if you don't touch any overclocking settings. The card will run better if it can maintain better temperatures. Now, what you might notice is these cards all look very different, but for some of them, the differences are more superficial, whereas for others, the differences run quite a bit deeper. Most of the cards are pretty much the same length and the same height, with one major one that stands out, and that is the ASUS DirectCU 2 card, which is both longer and taller than a standard GTX 780. So without further ado, let's go through what makes each of these special. This is EVGA's standard reference card, and that means it is a reference NVIDIA card, so you have that polycarbonate window on the extremely sexy aluminum cooler that looks just like the GeForce GTX Titan, except that it is, of course, slightly less powerful, has less RAM, and doesn't have that same double precision floating point performance that the Titan has for guys like CUDA developers. Next up, we've got MSI's gaming card, which uses an evolutionary step forward in their twin Frozer cooling concept. So you've got a large aluminum heatsink array. You've got a super pipe, which is MSI's branding for thick 8mm heat pipes, and 2 propeller blade fans with dust repulsion technology. So what they do is they spin backwards when the system starts up in order to pull dust out of the heatsink, making it less likely to get all caked on in there. Galaxy's Galaxy Clocked card uses 2 Zerba blade design fans with fluid dynamic bearings, which should give you longer life and quieter operation, as well as a hybrid aluminum copper design for the heatsink fins. So there are 4 copper heat pipes carrying heat out to it, and the copper core is right at the middle of the heatsink fin array. So this should give slightly better heat dissipation than an all aluminum design. The EVGA Superclocked ACX card actually has a couple of advantages that are obvious when you just look at it. Number 1 is aesthetics. This thing looks dead sexy. Number 2 is the extremely large aluminum fin array that covers pretty much the entire top of the card. Speaking of things that cover pretty much the entire card, they've got what they're calling a reinforced base plate that sits over top of the memory and other components that does a couple of things. It can help with cooling a little bit, but don't expect it to do a lot in that regard. But number 2 is it can help reinforce the card in terms of rigidity. Now, backplates help with this as well, but what backplates can sometimes do is reduce clearance with the card above. Last but not least, EVGA is using double ball bearing fans that they're claiming up to a 12-year lifespan for. Gigabyte's WindForce card is probably the biggest departure from a reference card so far, because Gigabyte has made some changes to the same PCB that's being used in all 4 of these cards. They're fairly minor changes, and mostly here at the back of the card, but they have made some alterations in addition to the cooling. So for cooling, they're using their WindForce cooler, which has a 3-fan design, the only one that we've seen here. Remember, smaller fans can sometimes have a bit more of a high-pitched noise, but we can't fault the WindForce cooler for pure heat dissipation. It can achieve up to 450 watts of heat dissipation while maintaining reasonable temperature levels. Gigabyte also has their own solution for card rigidity, and that is this reinforcement brace up here at the top of the card that does help to make it a little bit more solid in the PCI Express socket. ASUS's card, well, this one is kind of the big kahuna when it comes to the technologies that they've built into it. So they have their massive DirectCU2 cooler, which includes a CoolTech fan, which is designed to disperse airflow outward away from the fan, not just down, so it can take better advantage of what is the largest aluminum fin array out of all the cards that we have here today. Speaking of largest, they also use the largest diameter fans and the largest heat pipe. ASUS has a 10mm heat pipe on their new DirectCU2 GTX 780, which is just like, I mean, it's about as big around as like a lady's pinky. I mean, my pinkies are kind of fat, or like a child's ring finger, whatever. Anyway, the point is it's very large around. It uses a single 8-pin PCI Express connector and a 6-pin PCI Express connector, just like all of the other ones, and has a full backplate in addition to reinforcement aluminum bracing here. So it's extremely strong, extremely sturdy, and extremely overbuilt. It uses a fully custom PCB that is a completely different size from the original PCB and uses completely different components. So they're super alloy power components. ASUS is claiming will give you better efficiency, longer lifetime, and lower temperatures, in addition to the massive cooler that they've put on this card. Now, when it comes to performance, there's no real surprises. Both the Super Clock from EVGA and the Galaxy Clock from Galaxy were clocked at 967 megahertz base, with boost clocks going up from there, and they both, of course, performed better than the other cards here on display. The worst performing card was, of course, the reference card at reference clock speeds, because all of the other cards are overclocked to varying degrees, as you can see on the graphs that we have overlaid in front of you. Now, when it comes to cooling performance, we can see that the reference card trails significantly behind the other cards here today, for the most part, with the exception being the Galaxy Clock, which runs at the same temperature as the reference card, but performs substantially better because of its higher clock speed and the tuning that Galaxy has done with respect to probably operating voltages. Now, all the other cards run about 10 degrees cooler than these cards, making them look like pretty similar options from a price to performance to cooling perspective. Thank you for checking out this overview of the various GTX 780s available to you. We know there are several more available, but we felt like this was a good cross-section of what you can buy, and I hope that you enjoyed this graphics card overview. Let us know if you have any feedback for future episodes like this, and make sure you're subscribed to check out more videos like this from ncix.com.